We're going to divide complex numbers now. Now what this means is we can't have an I in the denominator. So if we do have a complex number divided by a complex number, and we have an I in the denominator, for example, if I have 3 minus 2i divided by 5i, a simple way to get rid of the I in the denominator, where that 5 next to the 5, is I'm going to multiply by the number 1, but I'm going to multiply by I over I. What that's going to do for me is give me up top, I'm going to use the distributive property, so I get 3i minus 2i squared over 5i squared. Now, ideally, that's going to get rid of that I in the denominator, which it actually will. So up top, I'm going to have 3i. Now, the minus 2i squared becomes plus 2. And down below, the I squared next to the 5 becomes a negative 1, so I get a negative 5. Now, I want to rewrite it in standard form, which is the real part plus the complex part, so a plus bi. So I'm going to rearrange this and end up with negative 2/5. I'm going to break it up into two separate pieces. Minus 3/5 times I. And now you can see A in this case is the negative 2/5, and the B is minus 3/5. I just broke the fraction up and flipped it around a little. So my final answer is negative 2/5 minus 3/5 I. Let's try another one. So I'm going to start out with negative 7 plus 2i over negative 4i. I'm going to apply the same strategy and multiply the top and bottom both by the complex number I. Up top, I'm going to get negative 7i plus 2i squared all over negative 4i squared. Now up top, that simplifies to negative 7i minus now 2, because the I squared becomes negative 1 and changes the sign. Down below, I have negative 4 times negative 1, which just gives me a positive 4. Remember, that I squared becomes a negative 1. Now I'm going to flip it around a little and reduce my fractions. I'm going to end up with negative 1/2 minus 7 over 4i. So negative 1/2 minus 7 over 4i is my final answer. That is in standard form, the a plus bi form. If you can, you always want to write your final answers that way. Now we're going to do a different type of problem, and I'd like to recall a rule. You've seen this rule many times before. This is called a difference of two squares. If I had a plus b times a minus b, if I FOIL that out, I end up with just a squared minus b squared. Now the nice thing about this is I end up squaring the a and squaring the b, which hopefully is going to get rid of an I if necessary. So let's try this example here. And actually, before we do this example, these two, when they're the same but opposite, we call these conjugates. And we are going to force this condition here in just a moment. So for the example, 4 minus I divided by 3 plus I. If I just multiply the top and bottom by I like I did before, in the bottom, I'm still going to end up with a 3i, and I still have I there. So what I'm going to do is I'm going to force the above condition, and I'm going to multiply by the conjugate of the denominator. Since I have 3 plus I, the conjugate will be 3 minus I. And then I force that difference of two squares that I have up above. Of course, whatever I do to the top, to the bottom, I have to do to the top. So up above, I'm going to end up with foiling 4 minus I, 4 times 3 is 12. The outer terms are going to give me minus 4i The inner terms will give me minus 3i. And negative I times negative I is plus I squared. Now down below, I have forced that difference of two squares. So I don't have to FOIL it out. I'm going to end up with 3 squared minus I squared. Up above, the plus I squared at the very end becomes a minus 1, so I'm going to end up with 12. And I'm going to combine up my like terms to give me a minus 7i minus 1, because that I squared becomes minus 1. In the bottom, 3 squared is just 9. Minus, parenthesis, I squared is negative 1. Be really careful with that double negative. Very easy to miss that. Combining the like terms up above, I get 11 minus 7i. Down below, 9 minus negative 1 gives me a 10. And I'm going to rewrite that in standard form so we can clearly see the a plus bi. So I'm going to get 11 over 10 minus 7 over 10i. And that is my final answer. We're going to do one more example. We're going to have 5 minus 2i over 5 plus 2i. Now in this case, the conjugate for the denominator, because we're trying to get rid of that I, is going to be a 5 minus 2i. That's going to force that difference of 2 squares. Up above, I'm going to put the same thing. I'm going to notice that the numerator of the original problem on this one is the same. It's 5 minus 2i 2 times. If you know how to do, there's a rule where you can actually square it. That's fine. You can use that rule. We're going to actually FOIL it out. So up top, we have 5 times 5, which is 25. The outer terms are minus 10i. The inner terms are also minus 10i. And the last terms are going to be negative 2i times negative 2i gives me plus 4i squared. Down below, I'm going to use the rule that I have above, the difference of 2 squares. I'm going to end up with 5 squared minus 2i squared. Up above, I have 25. I'm going to combine up my like terms to get negative 20i. And the plus 4i squared becomes minus 4, because the I squared is negative 1, so it changes the sign. Down below I have 5 squared, which is 25, minus 4i squared. Don't forget to square the 2. It's not just the I that gets squared. Up above, I'm going to combine up my like terms and get 21 minus 20i. Down below, I have 25 plus 4, because the I squared changes the sign. Combining my like terms down below, I get 21 minus 20i, all over 29. And I can rewrite that in standard form. 21 over 29 minus 20 over 29. And that is my final answer. And that's how you divide